Hello everyone. This video covers the lecture notes for week number 10. Before we go to week number 10, let's just review what we have done so far, because we have done many things that are connected, and what we're going to do in week 10 is just an addition to the stuff you've done so far. What we have done in the last few weeks, you usually have a polynomial, okay, like this. And so far, what we did was, there was a section where you had to find the maximum or minimum. Remember, this was the relative minimum, this was the relative maximum. In the same section or another section, they ask you to find what is this increasing. So it was increasing after here, then it was decreasing, and it was increasing. The last week, they ask you to find the X-Intercepts, which clearly are these 3 points. And the last quiz you have was, where is this positive? Well, positive is here. Where is this negative? Was here and here. So that was that's what we did last week, or week 9. And also in one of the past weeks, you can pick the graph and move it either left, or move it right, or move it up, or move it down, or reflect it on the y-axis, reflect it on the x-axis. So the thing that we're going to do in this section, or this week, is what is the n behavior. So for this week, for week 10, we're going to focus on the n behavior. And n behavior is just a fancy way to say what happens to y when x goes either to infinity or minus infinity. Okay? For example, if you look at this graph, clearly as x keeps getting bigger and bigger, y is going to infinity. And as x goes to minus infinity, y goes to minus infinity. So that's what we mean by n behavior. Let's go to the next page, which is the official start of week 10. But I already told you the main idea. So let's go to the next page. These are the 4 main outcomes that we want after we finish this video. So students should be able to identify the graphs of x to the n. This is very, very important, not just for this class, but for calculus. This is when x equals to 1. This is when x is 2, x is 3, x is 4, and x is 5, and so forth. You can see that when it's add, it goes from negative to positive, like this, like a snake. If it is add, it could also do this. Notice that if it is even, it will look like a parabola. So you have x to the 6, it will look like that too. So this is something that everybody should know by heart. So this is for x. This is x to the first power. This is x squared, x cubed, x to the 4, and x to the 5th. The last 2 objectives is what I just told you in the last page. You want to determine the n behavior and how to write it correctly using interval notation. All right, so notice that based on what we did in the previous weeks too, if you look to this graph, if you rotate it on the x-axis, you end up with this graph. Now, if you take x to the 4, which is this one, and you rotate it 2 units to the right, you get this equation, and this is how we end up with this. So you move it 2 to the right. If you look to x to the 5th, if you rotate on the x-axis and multiply by minus 2, and then move it up 4 units. Remember, the minus 2 means vertical or horizontal shrink. You should review what that is. and then you will end up with this graph will give you this. If you move it at 4, you flip it on the x-axis or rotate on the x-axis and multiply by -2. Now, before we go any further, let's make sure that you understand what polynomials actually are. This is a polynomial. Notice how it's smooth and continuous. That's what continuous means, that there is no holes. Now, this is not a polynomial. This is called actually a piecewise functions, but notice that this is not continuous. There is a discontinuity here and a discontinuity here too. This one is continuous, okay, but it's not a smooth because it changes. Here the slope is positive, and this corner it drastically changes to negative, and the same thing on the cusp. This is why this is not a polynomial. This is still a continuous function, but it's not a polynomial. So note, okay, this is an important note. All polynomials are functions, but a function doesn't have to be a polynomial. Okay. So this is very, very important. And here is 2 examples of that. If p of x equals to x cubed plus 3x squared, this is a polynomial, and it is a function. While f of x equals to the square root of x plus 5 is a function, but it's not a polynomial. Okay. All right. So let's get the official definition of polynomial. A polynomial is something that looks like this, where n is non-negative, and actually n has to be a whole number. Okay. For example, we have functions like this in the previous weeks. You even had this on the exam. X to the 4 plus x to the 5th. This is a polynomial because the value for n here is 4 and 5. But if you have p to the x equals to x to the 1/4 plus x to the 1/5, this is not a polynomial. So the exponents have to be whole numbers. And then the numbers in front, which is these ones, they are called coefficients. Okay. A0 is the only one that doesn't have a x associated with. So that one is called constant. So that's the constant term. Or is also the y-intercept. Now an is called the leading coefficient, and xn, which is the biggest power, is called the leading term. Not very original names, but that's what they're called. So this is the leading term. And the leading term is the one that's going to determine the shape of the graph and everything. Now the leading term also gives you the degree of the polynomial. So the degree is the biggest exponent. Therefore, for this example, notice that the biggest exponent is 5. So this polynomial is a 5th degree polynomial, and the constant coefficient, the one with no x, is the number 2. So therefore C0 here is 2. Here A1, sorry, I mean A0, not C0, A0 is 2. Okay, so in this case A0 is 2, A1 is -3, A2 is 4. Now notice that there is no value with x cubed, so this is a 0. This is also a 0. there is a value with a to the fifth, which is 10. And this is 0 and this is 0. Actually, there's no need to go any farther than this one. Now the leading coefficient here is 10, and the leading term is 10x to the fifth power. Now, I already mentioned this part. The end behavior is technically what happens to y as x gets bigger and bigger or smaller and smaller. So now this is just a fancy way to write it. So as an example of the inputs of x getting large in the positive direction, for x usually starts in 0, and then you can go to 1, you can go to 10, to 100, 1,000, and finally it's going towards infinity. The notation is going to be this: x goes to infinity. If we go in the negative direction, well, you start in 0 again, then this goes to -1, -10, -100, -1,000, -10,000, and so forth until you get to -infinity. Okay? All right, so let's look to this graph. You have the graph. It's pretty easy to determine the end behavior. So let's start with the first one. This one is actually supposed to have errors, otherwise the end behavior makes no sense. So it's just a typing issue. So but here it is. Let's look to the first question. Here you can see as x goes to infinity, as x keeps getting bigger and bigger, you can see that the value for y goes to -infinity. This implies that y goes to -infinity. And also as x goes to -infinity, which is this direction, you can tell that y is also going to -infinity. So that's what we mean by end behavior. So you have a graph, it should be obvious. So you look to this one, as x goes to infinity, you can tell right away that y is also going to infinity. And as x goes to -infinity, well, y goes to -infinity too. So you can see that here. Okay? And for this one, well, as x goes to infinity, y goes to also infinity. And the same thing happens as x goes to -infinity, y also goes to infinity, which again is obvious from the graph. As you move to the right, this goes up. As you move to the left, this also goes up. And then finally, you look to this one, you can see here in this one, as x goes to infinity, well, y goes to -infinity, and as x goes to -infinity, y goes to positive infinity. So you can see this is very, very simple. Okay, straightforward pretty much. Now, in this example, the table is telling you already where this thing is going. But notice here, this is a fifth degree polynomial, and the fifth degree, since this is odd, remember, since this is odd, it's going to look like this. Because you multiply by a negative, the graph is going to look like this. That's the dominant one. And then that the other ones don't matter, but you only look to this. So the graph is going to look something like this. In this case, you have the table to verify the values. But you can see as x gets bigger and bigger, which means we go this direction, you can see that the value for y is going to -infinity. So that's the case here. As x gets bigger and bigger, you can see that this is going to -infinity. Okay? So here the leading term is this, which as x goes to infinity, this goes to -infinity. This one is going to infinity, this one is going to infinity, but the dominant one is this one. So therefore, it doesn't matter what these two are doing. You only focus on this. So this will go to minus infinity. Now, in a nutshell, the leading coefficient or the leading term determines the end behavior. So you don't have to look up to the rest. So you focus on this one, and this is what you need to be aware. If n is odd, so that's the first part you should check. If n is odd, and if the leading coefficient is positive, then the graph is always going to look like this. It's going to start in the negative side. It can do something here, but then it has to end up like that if it is positive. If the leading coefficient is negative, then the graph will look like this. Okay. So therefore, the end behavior will be the following. Y will go to infinity as x goes to infinity, and y will go to negative infinity as x goes to minus infinity. So you can see that. Now, if this is negative, which is the case for the problem we did here, okay, then if that's the case, then the end behavior changes to this. As x goes to infinity, this will go to minus infinity, and as x goes to minus infinity, y will go to positive infinity. Now, this will be the case every time the leading term has an odd exponent. Okay, so now what happens if the leading term is even? Well, let's go to the next page and find out. If the exponent is even and the leading coefficient is positive, then the graph is going to look like this. It could do as many things as you want here, but eventually it's going to go up like that. And if it is negative, then it will start here and it will go down like that. So therefore, the end behavior is the following. As x goes to infinity, this will go to infinity, and this will go to infinity, which you can see here, here, and here. In this case, as x goes to infinity, this goes to minus infinity, and this goes to minus infinity too, which is, again, pretty simple. Right, so once you understand what I just told you, then to find out the end behavior of these questions, it should be self-explanatory. Remember, you only focus on the leading term, which for the first problem is this one. Second problem is this one. The third one is this one, and so forth. So let's look to the first one. So what will be the end behavior? Well, since this is odd and the leading coefficient is negative, as x goes to infinity, this goes to minus infinity, and this will go to infinity. Remember, the graph looks like this. Okay. Now the next one, this is even, so n is even here. So the leading coefficient is positive, so the graph will be like this. Okay. So as x goes to infinity, this will go to infinity, and this will also go to infinity. You can see it from here. So again, this is self-explanatory. Okay, now in the next example, you can see that the leading term has an exponent that is odd. So here n is 7, which is odd. The leading coefficient, which is a, is positive. So the graph is going to look like this. Okay. So you can see that as x goes to infinity, this goes to infinity. As x goes to minus infinity, this goes to minus infinity. And yes, it is that easy. That's it. Right, now the next one, here, the exponent is even, but the leading coefficient is negative. So that means that the graph is going to look like this, or just like this, depends on what you have. So you can see as x goes to infinity, this goes to negative infinity, and the same thing happens on this side. So both of these will be minus infinity. All right, so let's look to the last example, which is a very good question to have on the test. So this is what the question says. Let f of x be the following function or polynomial, which of the graph below could be the graph of f? So say there could be more than one, which one says it could be, and explains how you know the incorrect graphs are wrong. Okay. Now again, the leading coefficient here is the leading term is minus xq, where the leading coefficient is negative. So therefore, the graph for this one is going to look something like this. Okay. So therefore, automatically, this one is done. So this one cannot be part of the answer, and this one cannot be part of the answer. Because remember, it has to go from positive. It can do whatever wiggling it wants here. Then it has to be negative. So therefore, this one cannot be. This one cannot be either. So these two could potentially be the solution. So it could be this one, which has the right behavior, or it could also be this one. Now, since here is just asking which one could be, if you pick this one, you're technically correct, and you pick this one is also correct, because it doesn't ask you to find the exact graph. Okay. However, since this is a xq, that means that at the most, this is not what the question is asking, so I don't expect you to do that now, but it would ask you this in the future lectures. So this one means at most has 3 zeros, which we talked about zeros last time. Notice that this one has 1, 2, 3, but this one has 1, 2, 3, 4. So for that reason, even though this has the right shape, this cannot be the graph. So the actual solution in this case is this, and that's it, right? Again, this section is pretty simple. All you had to do was technically find the end behavior, know what actual polynomial means, what is the leading term, the leading coefficients, and that's it. So it should be very, very straightforward when you have this on the quiz or the exam.